Good evening, all. Sorry, I can't able to reach by afternoon. So today we'll be seeing about the counter with the pro two types of projects, how they are implementing, how the paper has been written, and what are the parameters they are handling, and why they are handling the parameters, and how they are making the map for the algorithms. Those things will be going through on. Okay, because uh, actually communication system is a vague area. You can't able to realize what is happening internally. You have to go through one by one, then only you can get some information and why they are doing those things and all. You can get into your ideology. So and what I'm explaining that won't be get you won't be get immediately, because I am also when I started my career. I started carrying by my career by before 7 8 years before. On that situation, I also don't know more things. So I also don't know nothing. Like I was starting with the basic things with Matlab on. It taken 4 months on the period. So it will be somewhat complicated, but you have to know it nook and corner. Then you can make more information, and it will be worth your. Plus communication systems. If you fail into communication systems as your engineering life, and you might have a bright future. I can assure that. It's not like IT companies with the Java and the programmings and all. It will be like how to say means it will be like a solution provider. Plus you will be like a targeted person. Like you are if you know the knowledge, you don't want to worry about your job. So communication engineer, lot of engineers are wanted only till now. If you see in the network, in the market, for how much communication engineers are available, means it's much more low. There is no much more communication engineers available in the market. Okay, so I'm telling market means professionals are not available. So always communication engineers wanted is there. Plus this is a research field, so the life span is also always increasing high only. Yesterday I told after 20 years also the same communication research will be happening. Now we are doing the 5G. The 5G will have a different modification, and with that the researches will be going on. So you have to learn by daily basis, then you can get some information. Then if you get into a professional level holder, then it will be easier to go up. Okay, so first of all, here I yesterday I couldn't explain the code clearly. I'll explain it once, and after that I'll go with a new paper with IEEE, which is written on 2016. Actually, why I'm using that paper means it was somewhat clearly explaining the counter concepts. So I'll be using that paper, and I'll be considering the parameters, what are the interference handled, and how they are making ideologies to rectify the interference, and what are the algorithms they are proceeding. Those things will be considered. Okay, so just start. So here, first of all, in this program, yesterday I shown this program that multiple array of multiple array users have been acknowledged the secondary user and primary user in a network. So in this network, I'm going to allocate the power equally. So that was the phenomenon ideology we have taken in this methodology. So first of all, I'm considering the Rayleigh fading channel. Rayleigh fading channel. What do you mean by Rayleigh fading channel? Don't ask more. It's a easy thing. Like it's a one normally noisy signal. Just consider it's a noisy signal. Okay. So it will be like okay, it will be like something randomly nice signal. This is like some random nice signal. Okay. So how will you calculate that in a value? You can ask me again. So what will be happening means one defining one channel. It will be happening like with what's the time delay we are taking as a response, and it's a frequency. Frequency means within a 1 second, what is the signal we have taken. So that is a frequency. So with that frequency only will be taking into account, the channel will be taken. So if the channel is taken, you can ask me how you are representing in a value. It's a signal how you are representing in a value. So normally any signal can be represented with the cos theta base plus I sin theta. Okay, I minus I or plus I. It's based on the modulation and all, and what's the parameters we are taking. So these are responsible signal representation. So while representing here, we will be representing the values with the theta organized. Okay, so here something like 0.9 or minus 0.1. So that like will be taken. So these value is the channel here. So for this signal, what is the cosine phase and sine phase will be taken. So phase means angle. The angle change will be taken. So with that, the signal will be represented. Okay. So that is the signal available here. That is represented as channel. Okay. So when you are having a message signal, that is also represented in the same methodology. So the message signal and this noisy signal. So our message signal will be like this. So the noisy signal will be there. Both will be collided. So while colliding, automatically with the signal will be noisy. Okay. So but we have to identify what it is available in the receiver, because the receiver doesn't knows what you are sending. Okay. Because this is a transmitter side level happening with the media transmitter side is happening here, and the media engagement is happening, and we are receiving in the receiver side. Okay. So receiver doesn't knows what happened in this channel. Plus there will be noise also. The noise is like a addition of a signal. Okay, why I'm telling addition of a signal means when I'm speaking, any other people is speaking means that's a noise for my signal. Okay, so likewise also here also the noise will be engaged. Okay, so when you are considering these signals, so likewise the same time period there will be noisy signal also will be engaged. Okay, this noise response is based on the dB. Okay, so SNR we might study. Okay, signal to noise ratio. So with this dB only, this noise response will be acknowledged. If the dB is higher, automatically the noise response will be low, very low, very much low. If the dB is lesser, then the noise response will be very much higher. Okay, so first of all, we know this, and the channel has been added, multiplied, and the signal noise has been added, and the signal receiver has received a signal. But the receiver signal, what it is sent, it won't be there. Here the signal will be this like. This is the signal sent, you consider, and the signal this is signal is received. So what the receiver will do means the receiver will evaluate this channel. Okay, the evaluation of channel, how it will be happening. I will tell you an example. Okay, for how evaluation of channel is happening. Like you just consider I'm having a one object, like I have a gift I have to send to a person, and the person is available in another end, that is from 1-2 kilometers you consider from distance. Okay, so I am giving the object to the person, some other person. I'm not the person going, some other person I'm going giving the object, and I'm making the object to receive the other end person. Okay, so the person should reach this 2 kilometer in 10 minutes. Okay, just consider the 10 minutes he have to reach the distance, but he is not reached after 20 minutes also, he is reaching after 30 minutes. When we are asking now the issue is the person after reached with 10 minutes the time delay, but it is there. He reached only 30 minutes. So what they will be doing? So we will be asking the person what is the delay. Okay. So the same thing only here also. So what we will be doing means we will be object is the message here. The person is the channel we are encoding. Okay. Encoding means we are adding a some representative channels. Okay, the channels won't change with data, just consider. Okay, if I'm sending the data with 1 bit means always with the higher bit, higher signal means the same higher signal will be transmitted. Okay, so likewise another signal is taken, this is a message signal, another signal will be uh, a signal which is given the original 1 bit, same data will be transmitted. So what will be happening, the receiver knows first channel and third channel are the known channels for the receiver. So receiver will estimate these two channels. Okay, so what will happen if you are estimating these frequency, this frequency and this frequency, there won't be a more changeover. Okay, so that we can estimate this channel clearly. So if you estimate this channel, we can estimate the nearby channel. So this was a simple logic happening with the transmitter. So this is called pilot insertion. Okay, pilot. So pilot insertion means these are pilot channels. So pilot channels means the pilot will drive the signal. Okay, the nearby message signals. Okay, so pilot will be helpful to reach the nearby message signal. So only it is named as pilot also. Okay, the pilot signals are named that like only. So if a person is, just consider the same scenario, the person is delayed means you won't be asking the object, you'll be asking the pilot who made that signal to be delayed. If the signal is getting delayed, if the signal is getting faded, or sorry, faded or delayed, okay, after that, if the signal is getting noisy, all the things will can be evaluated with a single channel, which is called the pilot channel. So the pilot channel is the defining parameter of a signal transmission. Okay, this thing is not related with cognitive full concept. This is a basic communication system, how it is happening, because the receiver always doesn't know any data, but the receiver have to be educated with the data. So how to be done, for that only these methodologies is followed. Okay, pilot insertion is a technique added with the for identification of the signal which is transmitted over the network. Okay, so so with this, if we go below, I'm going to consider 4 channel with 4 subcarriers in each channel. So with that, I'm defining the aliphatic channel. So with that, channel state information is defined. So channel state information is randomized aliphatic channel with this number of channel with subcarriers have been defined as a channel state. Okay. So with this, I'm going to define a primary user radio. Primary user radio is equal to number of channels I'm defining. Why I'm defining like that means if 4 channels are there, primary user 4 channel. Okay, that's what I'm considering. Okay. Secondary user radio, I'm just considering is a single user is available as secondary user. So what will be doing a secondary user? The secondary user will be going and approaching the primary user signal. Okay, so while doing that one, so if the primary secondary user have to achieve the primary user and reach the get the signal means that network should have should support also. Okay, because the primary user channel is allocated to the one base station, the base station have to support whether the secondary user should be allocated or not. Okay, so with this primary user radio and secondary user radio, I'm creating a positional vectors. This is also randomized positional vectors within a particular location I'm creating. Okay, so if you see the diagram, you can get it. If you see here, this is the secondary user radio region and the secondary user base station I'm considering here. And with these, the secondary users have been placed over here. Sometimes the the primary users are placed over here. Sometimes the primary user won't be in the second primary user region. It will be above the primary user region. On that sequence, we have to give the signal. So the base station here is available for the primary user radio signal, and the secondary user signal is just considered as a Wi-Fi signal. This is considered as a 4G signal. We just consider. So 4G signal will be given lot of distance. Okay. So on that situation, this user doesn't have the radio communication with the 4G. On that situation, it will go and search for the nearby communication region. So I'm giving a nearby communication region. It's a second Wi-Fi network is available inside the nearby. You just consider. So on that situation, this device will try to hop with these secondary user base station. Okay, like modem, Wi-Fi modem, just consider like that. Okay, so it will be going and approaching these base stations. So while approaching these secondary user modem should have the more channels. Okay, if the channels are higher only, it can be allocated. Okay, so for that, these will be sensing on that one. Okay, so on that situation, totally just consider there is a 16 users in the primary user network. On that 16 users, I have given, and the 16 user network, so one user is out of range of this primary user network. So this network should approach the secondary user. So secondary user, just consider already it is having some 2 users available. I didn't notify it here, but just consider it is available. 2 users are there. So the Wi-Fi can able to provide up to 5 users, but here I'm just telling the 2 users only capable of the network. You just consider. So on that situation, this is going to approach this network means it won't be able to provide. It will make the situation to be queued. Okay, so these things should be liberated properly, so that only what the primary user radio is doing means, here we are not going to make the secondary user network capable of rectifying the solution. We are making this primary user network to be capable in this project. Okay, so what we are going to do means, we are going to use a multi-array antenna in the base station. So with that, we are going to equalize the power. Okay, so based on the distance between the this user and my base station, this user and my base station, this user and my base station, this user base station, on the situation where the antenna should be focusing. So based on that, the channel power allocation can be equalized. So I am estimating the channel power for each and every devices with the information passed from the device to the base station. So with that, I am going to define finally which is the efficient device to equalize the power. So we are equalizing according to that with all the base station. Based on that equation of powers, we are allocating the antennas. So based on that, the antennas will be allocated and the power will be equalized. So here I am creating the network accordingly. For that only these all the definitions are happening. The rectangle and circle, all the things are based on the creation of the network. The network creation possibility only is created. Okay, after that, with the channel state information, what we are going to do means, we are going to estimate the secondary users powers accessible. Okay, so for that, what we are going to do means, we are going to estimate the power of the original estimated power with the defined power of the channel. Okay, so originally estimated power is like an average power, just consider equalized power, just consider. Okay, so the first channel will have a 5 dB as the power, the next channel will might have a 10 dB. Okay, on that situation, these estimated power and the new power will be subtracted, because the secondary user count will be identified here. With the subtraction, based on that, it will be trying to equalize the power. Okay, so these will be happening in a looping process. When the estimated power tries to be equal, on that situation, this will be subtracted, again it will be looping down, and again it will be subtracted until all the channels try to equalize the power. This will be looping down. Okay, so with these power channels equalized, we are trying to identify the power capacity of the channel. Okay, for that only here waterfalling methodology is used. So here it will be coming for the channel power calculation only is happening here. So here we are starting to do the while loop process, which is iterative equalization process. So which will be here we are identifying the power what is estimated with the original, with the difference of differentiable power. Here we are trying to equalize the power. Okay, just so both scenarios. So here one scenario is for estimating the power and another scenario is for equalizing the power. Okay, so equalizing the power will be happening with the finding methodology of which is a starting power to the ending power. So with the negative position and positive shading, with that it will be identified. If it is negative, it will be decremented. If it is negative, it will be incremented, and it will be positive, it will be decremented according to that. So based on that, we are allocating the power, and finally we are making the bandwidth allocation to that one. Okay, so multiple high bandwidth is available means how the capacity will be increased, that will be analyzed. Like we are always estimating for only one channel what is the estimated power. On that basis, we will be estimating for a bandwidth. If you are estimating for one channel with we are getting 7-bit 6-bit in a channel, with one channel means we can do for 1 megahertz channel means it will be multiplied automatically. So 6 Mbps will be getting on. So on the 6 Mbps, we are using a multiple techniques for the modulation like QM, PAM, and all means it will be multiplied again. So because we are using a 64 QAM means we can send 64 bit in a single carrier, same data, same time period. Okay, so automatically 64 by 6. So it will be going around 360 Mbps. So that like only we are reaching the more capacity of data rate. So that is here we are showing only the equalized power how to be made, and with that how we are giving the data. That is part of the ideology here. Okay, you see the first 4 channels will be allocated, next 8 channels, and based on the equalization will be there the at the downwards, like the red color regions are showing the equalized data, okay, equalized power for all the channels. With 16 channel allocation, 4 channel allocation, whatever channels are allocated, it will be looping down to equalize the power and give the estimated power possible. Okay, so that is a given solution over here. Okay, so in these this is the one type of methodology for equalization power based concept. But always this is a old based technology only, technique only. So nowadays it have some advancements in these techniques and all. So for that we are going to analyze this one. Okay, this is a joint beamforming power and channel allocation with multi-user, multi-channel underlay meso boundary network, radio networks. Okay, so first of all, I'll explain what do you mean by joint beamforming. Joint beamforming means there might be available with multiple antenna possibility for in the secondary user also, and the primary user also. Sorry, in the secondary users with the multiple antenna possibilities there means we have to make the beam forming efficient. Okay, so for that only the joint beam forming is mentioned this paper. This is a transaction PhD thesis happened around 2016. It's published. Okay, so with that only I'm going to explain this concept. So this is successful paper because why I'm telling successful papers means this has been referred mostly in the papers what is recently available also, like 2020 also. The most is reference paper is this one. Okay, so for only I'm going with this paper. So if you consider joint beam forming, it's making the multiple antenna approach with power and channel allocation will be there obviously. With in multi-user multi-channel interference regions. Okay, multi-user multi-channel means there will be multiple users with the primary users also, secondary users also will obviously will be there with the more number of users. That only is mentioning. Okay, so like this multi-channel networks. Multi-channel networks means like if you want to make a one-to-one communication, multi-channel will be happening on. So on that basis, multiple frequency based like Wi-Fi one channel frequency and there's a 2G, 4G on channel frequency. These based concepts are available means how to do that one. In the MISO means multiple input, single output. Okay, so why it is called multiple input single output means here in this paper we have considered the secondary user with multiple antennas for the reception and single output for the transmission. Okay, for efficient biasing of data. Sorry, multiple antennas for the transmission and single antenna for the reception. Why we are doing that one means we are making the secondary user to be efficient. Okay, not the primary user. Okay, if the primary user, if you don't have a signal, if you want to efficiently attack the network, then only you can get the data. Furtherly, we are enhancing here with multiple antennas has been deposited on a secondary user transceiver. That like we are considering. Okay, I will show the diagram, then you will get some information what I'm telling. Okay, Okay, so if you see, this is a diagram they have considered. Okay, so in this, if you check like that, so first of all, there will be a design. Sorry, there will be here the network is available. A central entity is there, centralized server, congregative server. You just consider like that. So here, if you see, there is a primary user base stations available. Here notified with the black color base station architecture is shown. Likewise, there is a secondary user networks is also available locally. Here also secondary user network is there. Here also secondary user network is there. Okay, so different secondary user networks are available in the locally also. Okay, so in this situation, if you want to make the secondary user to communicate between a secondary user receiver, just consider like that. Okay, so here is the secondary user receiver is available. This is a secondary user transmitter. Okay, so here in this network, if you want to connect with the these user means you can't able to connect. Okay, because you just consider you can't able to connect. Okay, these device have to connect with this device. Okay, don't consider this device. Okay, so you just consider this. Don't consider this base station. There is a device base station available. This secondary user network, these device want to communicate with this device. Okay, so in this situation it's not possible because the secondary user range is limited. Okay, so limited interference only available, so only we are mentioning the secondary user within this box. Okay, so if you consider on the situation, if you want to connect the secondary user with this second primary user means this is secondary user means it's not possible because this secondary user transmitter wouldn't be able to efficiently transmit to the secondary user receiver because of the high range of availability of the secondary user receiver. Okay, so here what now we are going to consider means we are going to approach a secondary user to primary user network. That's the obvious problem we are going to mention in the counter radio. So while doing that one, the secondary user tries to tries to reach out this primary user network. Okay, so on that situation, if the secondary user is trying to reach the primary user network means what are the situations will be happening, what are the problems will be happening. So that one we have to consider first of all. Okay, so I'm just considering this is a secondary user device which is named as K as the ID. Okay, the ID of the device is K. Just consider. Okay, likewise for the primary user there is a device also which is available in this local network. I'm just consider it as a N. Okay, so that is a mentioning available K and N is the primary user particular device we are considering. Okay, so likewise other than that some device will be there. Okay, always we won't be available only available in the network like me and any 100 persons will be there like a secondary user. So like me there will be another user also. Okay, secondary user RxM. Likewise there will be hundreds of users around that. Okay, so on that situation there will be a hundreds of users means these hundreds of users also should be considered and this primary user should be considered. Like this primary single primary user uh, uh, like the primary user, like multiple primary users also will be there. Okay, likewise the channels what can be allocated by the base station should be considered. Okay, so first of all you have to consider what is a secondary user considered and the secondary user multiple secondary user which is related to the secondary user nearby. Okay, like me what are secondary user available, those things should be considered. Primary user should be considered. The primary user multiple primary users will be there obviously. After that channel should be considered. Channels means the base station how much channel can propagate by the base station, that should be considered. Okay, so after that noise should be considered and antenna should be considered. Antenna should be considered means if the mobile phone you are here using, I'm having 6 antennas, you just consider. So 6 channels will be propagated, so 6 antennas will be propagating six information, six antennas will be propagating the signal. So 6 antennas will be propagated. For that also what methodology we are using, that will be different. We can use based frequency spectrum with based on single individual frequency application with beamforming and all we can do. So 6 channels for 6 antennas you just consider. Okay, so on the situation you have to consider the antennas also for the secondary user. So these are the things you have to consider. So the considerations what will be made means these are the considerations how they have made. What is a based on the symbol they have mentioned here. Here if you see so there will be channel secondary user channel to secondary user receiver. There will be channel secondary user transmitter with the secondary user receiver because while I'm sending the information, there will be another secondary user secondary user transmitter is also sending the trying to send the information to the secondary user receiver. So that should be considered. Like after that, the secondary user transmitted to the primary user receivers. Okay, because like secondary user transmitter will go and interfere with the primary user also. So on the situation, that is also considered. After primary user to secondary user. So primary user TX transmitter will be interfered with this secondary user receiver. Okay. So after that, we have to consider the primary user transmitter with the primary user receiver. Okay, that's also should be considered. Okay. So these are the considerations has been made. Okay. After that, large the coefficients, fading coefficients for now and transmit power is a constant one. After noise relationship between the primary user and the secondary user, those things will be considered. These are the things you have to mainly consider. With this, I'm moving out. So based on this consideration, this formula has been made. Okay. So what is the formula? Is means secondary user interference channel power retention. What's the power secondary user can get from the overall network? It is available. That is the formula going trying to mention here. Okay. So in this formula, there will be a channel. Okay, with the particular user, because if you consider the when y is equal to hx, okay, hx plus n. Okay, so hx means this is a hx and n. Why I'm telling this is a hx means here h is the channel of the primary user, secondary user, which is trying to transmit the information to me. One user is trying to call me, that user is called the primary, the secondary user, which is trying to, that is a needed network data we need. Okay, so that is considered here. With that, the uh, y is equal to hx. Okay, so with that we are analyzing the signal and the antennas also. W is mentioning here the antennas. Okay, number of antennas is trying to transmit, that power also is that power also is estimated. Okay, so with these thing, this formula has been given. Plus here next is this division is giving uh, the antennas not related to me with secondary users. Like me, some are secondary users will be there, right? So those users has been mentioned here. Okay, so here WM is the antennas of the secondary users which are not related to me, and the secondary user signal and the secondary user channel. Okay, so with that the power will be estimated. For only here it is an array. Okay, because it will be multiple users will be there, so multiple users interfacing, so that is called summed up. Okay, so already it's summed up, it's in array format. Okay, after that, plus if you see, it's a constant power generated by the primary user because of the channel allocation defined, because defined channel allocation is done, so only it is power we are initiating. After that, there will be a channel for the second primary users also with the power. Okay, so that is given here. Plus finally there will be a noise. Okay, so these things you have to consider properly. So this is the power estimated of the secondary user. For this single formula, we have to check what are the possibilities with this network. That is the initial thing you have to do. If you are going to make a research in the communication system, what is the network you are considering, what's the problematic situations are available in this kind of network. So with that, you can estimate the formula for the particular network. Okay, so with this next, I have to estimate for the secondary user also, like is the primary user also. So yn also should be estimated. If you consider yn, what will be the yn? Obviously this term will be coming on here. Okay, because this is the primary user power, so that will be here taken from here to here. Okay, so noise will be there, the noise won't be same, because the secondary user noise will be different and the primary user noise will be different. Okay, so that should be estimated, that should be taken into account. Okay, after that, the third thing, this will be the channel interference. Okay, this interference is came from here. Okay, here if you consider these, all the things are interference to the primary user. Okay, so what will happen, you can ask me where is the k, you are considering only the k, where is the other users. Okay, you can ask me. Okay, but here we are considering these interference only available, so here we are considering this one only. Okay, so other users interference we are not considering, only single user only we are considering to estimate. Okay, for that only we are doing this one, because primary user estimation we are not going to follow up. Okay, because we are only identifying the base say case scenario for a secondary user. So for that only we are formulating the formula. Okay, so for based on that, the formula has been made for the secondary user and the primary user. Okay, that is done. So now the prime formula has been made. with these formulas we can identify the signal to interference plus noise ratio. You know about signal to noise ratio. What do you mean by the interference means, here we are considering the interference, right? These things should be considered as interference. Okay, so this will be going on the division. Okay, because of these, it's a ratio, right? Signal to ratio, noise ratio. So interference plus noise ratio will be added. So interference plus noise ratio will be available here, and the first take will be the signal. So the signal will be taken back. So based on the interference and the signal, what is the SINR can be estimated. With that, we are going to do the logarithmic formula. With that, we are estimating the power. So this is the throughput rate. What can be estimated with the particular signal to interference noise ratio network. Okay. So that is simplified and shown here. Okay. So here, after doing this one, we have to make the formulation of the channel beamforming. Okay, so the beamforming methodology, for that they are going with two types of algorithm, which is genetic algorithm and similarity and linear algorithm, which are the optimization algorithms. Because why we are going to optimization scenario means, here if you consider there are lot of parameters available with lot of tuning. So in this we have to get the best case scenario which will be efficiently moving through to get the data efficiently to the users. Okay, so for that only we are going to consider the best case scenario. So on that situation, on that only the solution pattern has been made. Okay, so for that only we are working on. So that is the methodology mentioned over here. So based on that only we are trying to estimate the data. So here if you consider the formula is made to be same, uh, what is the optimization scenario will be going on the next. Okay, so here genetic algorithm, based on channel allocation is defined. So here what will be happening means, there will be a descending approach, best case approach and worst case approach. Three cases of approaches has been made. So with that we are going to make the best case solutions for the user. Okay, so based on that the data can be estimated. For that only we are doing. Okay, so genetic algorithm, if you consider initially there will be a chromosome population, so there will be a formula related with that. The formula, what are the tuning parameters will be considered on. So with that we'll be formulating the formula. So given is the tuning parameters. These are the tuning parameters. Here K is the number of user, N is the secondary user, primary user. Here Neta is a noise, I think, and after that pi is the phase, and Gmax is the power allocated, I think so. So these parameters have been considered. So based on that parameters, we are making the chromosome availability with the formula. What the formula we have, the same formula has been used here. Okay, so with that we are going to apply these values, because these multiple values can make multiple scenarios. Based on the values, the saturation curve may be going to peak or optimized on the region. So for that only we are making the optimization algorithm to be best at fitness to be taken. Okay, so for that here we are going to initialize the chromosome and we are going to justify the chromosome to the another id. So with that we are going to sort initially. In that sort we are selecting the best case the outcome, and with that finally we are making the worst case outcomes, and we are removing the worst case outcome from the best case. So with that we can get the best lucky outcomes between that. The worst case is not required and the best case is also not taken into account. So within that we are making the approach, because genetic algorithm is defined like that only. So with that we are differencing the both. With that we are estimating the luckies and g-luckies. Based on that, finally the crossover operation will be happening on. Crossover is a process happening between the probability of the best case and luckiest case. Okay, so making the probability between these both, and based on the probabilities we are making the crossover. Crossover means what will be happening exactly in the crossover means, two values will be taken into account. With that the one value will be estimated with the another value, and on the crossover process it will be binarily changed with the data. With the binary data it will be mapped with zeros. Zero will be mapped with one and one will be mapped with zero. Reverse mapping will be happening between the two probabilities. Okay, so that will be happening on. So based on that only we will be taking the information, and with this crossover the mutation will be happening. Okay, after the crossover is happened, the mutation, new data will be found. Okay, that will be taken into account. So new data is the probability what we have taken into account, that will be multiplied. Okay, the multiplication process will be happen. Crossover will be actually the genetic algorithm name, it says it's a genetic algorithm. So two generation of parents will be taken. So here the parents will be taken into account. So with that we are making the approaches of parents with the descending best case and worst case, and with that the luckiest and best case will be taken into account. With that we are making a crossover operation between the two probability of the best case and luckiest case solution data available. So crossover will be replacing the zeros with ones and ones with zeros, that will be happening on. And after that finally mutation will be happening. Mutation is a mutation between the two, okay, two data. Okay, after mutation automatically there will be a child. Okay, the child will be created, the two childs will be taken into account. Okay, the two childs will be taken into account. So with that the finally we will be having the child data. Okay, so that's the solution will be happening. Okay. Can anyone remove that one marking? Okay, after this is done, the final data will be taken into account. The child data will be the solution, but it will be not yet done. It will be looping on. Okay, because the solution will be again it will be got, and again the maximum solution, the minimum solution will be approached. So until it is getting the G with minimum, it will be approaching and again with the best case solution is got. So with this optimized solution, we will be taken into account for the G. Okay, G factor. Okay, this G factor will be taken into account. With that only we are going to estimate the power for the primary user. So sorry, noise of the primary user. I'm considering this as a noise, and we are eliminating this one. Okay, that's the ideology happening over the network. Okay, so with this basic, I have made the project coding. Uh, sorry. Okay, so here I have mentioned the channels or the possibility. Uh, so with that we are trying to decode the data, identify the best case data, and we are making the population of data rate what it can be uh, estimated. Okay, so here we are creating the channels for HSR, HRD, and HSD. Okay, So which is the channel for multiple users with multiple channel. Okay, so here we are considering the number of secondary user, number of secondary user receivers. Okay, so with that number of primary users also in the channel. So based on the channel allocation is done. So with that, if you see here, we are making the complex. Complex is the command is for cos theta plus sin theta. Okay, I sin theta. So this will be the cos theta data, and this will be a I sin theta data. Both are randomized data. Okay, if the complex will give a randomized data with this complex function. So with that, we will be getting the HSR and HRD and HSD. These things will be taken into account first of all. With this, we are doing the encoding technique. So encoding technique is the trellis encoding only. So trellis encoding you might see in the mapping based encoding between the actually encoding techniques. Why it is defined means always encoding techniques is for the mapping of the data which is can be demapped. Okay, so for that only encoding techniques is done. So encoding can be encoding will make the data to be efficiently the noise cancellation can be done in the receiver to estimate the original data what is possibly transmitted. So that only we are making the transistor encoding and all. So the encoding technique is defined here, and after that we are making the channel to be defined. Okay, HSR, HSD, HRD. For that we are making for the secondary user with the receiver, and secondary user receiver to the other channels, and the secondary user receiver secondary user to the primary user channels. So all the channels will be taken into account. With this, we are defining the best case, worst case scenarios. Actually, we didn't apply the genetic algorithm here. We are directly applying the best case, worst case manually with the value. Okay. So with the minimum probability is taken into account, minimum and max probability. So with that, we are estimating here, and we are checking the luckiest case also with manually. Okay, all are made as a manual process over here. So with that manual checking the information, it will be defined, and at the end we are going to estimate the power also. With the we are estimating for the same case scenario for 100 channels. So for only here it is initializes 100 channels. So with that, finally we are going to give the what is the channel capacity will be available. So for that only we are estimating the use cases what we are defining, like the algorithm based definitions is done. So based on that, finally we are making this one. Okay, so these will be finally will be plotted. Okay, so with this we are achieving the data, how much data we are achieving, that will be considered. Okay, actually I couldn't be able to execute this code in this 2020. Actually the code is different in 18. I'll just run the comparison plot and I'll show the what's the outcomes we have got. Okay, so here in this paper we just considered between the multiple algorithms with genetic algorithm, simultaneously, and a mixer algorithm, and df is uh, distributed for forecasted relay based technique. Okay, like when we if we have a user in the remote destination, we can map the same user with a multiple based hopping based technique. Okay, so for that only the df relay technique is shown here. That is also compared because it's a old technique. So only we shown that also, and after that with that df relay, DF and DAF is there. So with the DF and DF mixer, the information outcome is taken to here, outcome is here. And finally, we are making the simulated annealing and the genetic algorithm optimized based techniques. which is giving the efficient throughput data rate. Okay, so that is also considered here to make that one. So here, if you consider, we are considering only 5 dB to 10 dB as analyzing points. So with these points of data rate, in this one, we are how much data rate we are achieving. Okay, so this is for a actually this is analyzed for a single 1/100th channel availability. So if you consider this same for a one channel consideration, means there will be five initially for 5 dB, there will be estimated with 5 bits per second, and it will be going around up to 20 bits. Sorry, up to 20 bits the data rate will be achieved. Okay, so based on the NDSMR thresholds what we defining, we are getting this much data rate. The throughputs has been defined here. Okay, that's outcome of this concept. Okay, so here likewise there will be like for genetic algorithm separately it is shown. Likewise we are making the comparison between the plots based on that where we are getting also shown. Like we are similar to the similarity annealing and the genetic algorithm based on that what is the plot is done. That is also shown here. Okay, so um, actually we are speaking about the common radio and how it will be happening. Most of the people are be having a question how the future of common radio will be enabled in the mobile devices. I will explain that itself and I will close the session. So how it will be happening means nowadays the communication devices uh, have been enabled like one device with multiple antennas. Okay, so if you consider like it will be having a uh, for a for a Bluetooth there will be one modem. Okay, likewise uh, for Bluetooth or there will be one modem which is be working on 2.4 gigahertz. Likewise for Wi-Fi also there will be one modem because the protocols for Bluetooth and the Wi-Fi is different because the Bluetooth is uh, one-to-one device and the Wi-Fi is multi one-to-one device only, but it's like a router based joining. Okay, connectivity. Okay, so Wi-Fi will be there, that will be considered. After that there will be 1G modems. 1G modems, how you can ask where is the 1G modem is always in the mobile. There will be FM radios in the mobiles, so that is called 1G. Okay, that will be implemented 1G technique. So for that also modem will be there. And finally there will be a modem for 2G. Okay, so that modem will be separately available. So after that for a 3G one modem will be there, and 4G will be there will be a modem, and 4G there are a lot of spectrums have been allocated. So for that there will be multiple antennas, antennas will be there with the modem also. Okay, so this is the architecture. If you consider GPS also, the GPS also will take a modem. Okay, so there will be a modem for GPS also. These all combinedly architecture to make the mobile device. Okay, so nowadays mobile device have been acknowledged these like only. So but in the future there will be a common radio which is called SDR, software defined radios will be there. uh, so SDR is the concept featurely made proof. So if you are making the SDR, software defined radios as a solution, on that situation, all these devices will be combinedly taken into one device. Okay, so all the devices will be combined to one. Okay, so what will be happening? These will be changed into single antenna device. Okay, so single antenna will have all these possibility to process. Okay, so for that there will be a research for the 5G antennas in the projects also. There will be a research papers for the 5G antennas also. What we are doing in the mobile communication systems, the same thing will be followed up on the antennas also, because the physical layer we are working with the data link layer only previously what we have studied. There will be research papers with the physical layer also with the antenna designing also. Nowadays there are multiple antennas like multi-array antennas and all. So if we here see here, there will be multi-array antenna. So this is a multiple array antenna which is making the beam forming methodology to generate the signal. So based on this, we can generate the signal over the particular location. So in this corner, if you need signal, you can generate this. You can switch on this antenna because for that switching circuits will be there. The circuits will be defined based on the switching circuits. That based on that antennas can be emulated, can be switched on, and it can be transmitting the data towards the user. So for that only these antennas have been defined. Okay, um, So this will be that network architecture will be followed in the future, like is millimeter wave applications. Those things also will be concluded. Okay. Mm, I think that's it from my side. If you have any questions, you can ask me. I'm posting the attendance form link in the chat. I have posted the link for this session. Skumas are told to mention place this one. Can you for use for this for the attendance form? Any questions from your side? Any people having doubts or anything? Not the same concept. You can ask any questions also related to communication. Any questions? Or else I will close the session. I will be closing the session in 2 minutes.
Sir, one question in chat box, sir.
Yes, actually, the job opportunity is much higher only. There are not related. Actually, you'll be unique people when you feel start studying a communication core side, because all the people are going with IT. Okay, IT means with Java, Node.js, and all, and after that Python and some other things. Because here also, if you come, there will be programming language. Obviously, will be there. C, C++ will be there. But the programming, apart from programming language, you will be learning based on the technology. Because if you take the Java and all, there will be application oriented solutions. I'm not why I'm mentioning that things means most of the people will know about IT. Okay, for after engineering completion with ECE, most of people are jumping into IT. Okay, for only I'm mentioning that domain. Okay, so if you consider those regions, there will be won't be a unique people, because any people can go within that. If they study more, they can go within that. Okay, that is the advantage for them. But if you go these like means, if you go with VLSI communication systems and Android design, you need a lot of time to learn, because plus it will take more time to achieve your goal, because if you are working with antenna for 8 years only, you will be in a better scope. That is not possible within this age. Okay, so if you go with communication systems, you can make a growth, see the growth in 1 to 2 years. I can assure that one. Okay, with the communication systems, VLSI, and you try to go with the MATLAB with image processing or DSP signal processing. Those things are core areas, but you have to see the industrial standards what they are going on. Don't go with studies itself. If you try to go with the industrial standards also, uh, then you can get the opportunities more. For that, you have to be updated with the where you get again update. Get update mean go and search the best companies who are working in a field. If you want to check, get the field what is happening, they will be having their portfolios. Okay, what they are working, what's their futuristic aims, those things and all. So go and check that. If you want to go to the communication systems, go and check what is Snapdragon, what is happening in Snapdragon, what Snapdragon is supporting. Snapdragon, right? Which is a processor of Qualcomm. Okay, all the mobile phone chips processor are made with Snapdragon. You may see Snapdragon 730 gaming will be better. Snapdragon 815 highly costlier with 5G technology is there. Those things they are mentioning. Okay, so those things beyond that, what is there in that you have to know that one, so that you can start learning what's the possibilities also. I think I have answered it. Any other questions? I'll close the session. Okay, thanks for joining the session. I think it will be useful. If you have any doubt, any need support from Pantech, you can call us. Okay. Our website is there, pantechelearning.com, and you can approach the pantechelearning.com for much more informations, and you can reach out us. Okay. So here is our phone number. This is the official number. You can contact them for any information. We have multiple offices in the regionals also. You can check with us. And if you need more support also, you can contact us. Myself, Rajkumar, and more technology technical people are there. You can go and approach them to get more information. Okay. Okay, thanks for joining. Bye.